Hello, welcome back to the channel for another experiment using generative AI to support supply chain and logistics operations. Today, you are playing the role of the distribution planning manager of a fashion retail company that is based in France. So you have a central warehouse in the south of Paris that delivers stores worldwide. And as a distribution planning manager, you are in charge of the order creation, but also the deliveries to the stores. And you face a lot of issues. So stores are complaining about late deliveries. But when you go to the different teams, warehouse teams, road transportation, air freight, custom clearance, they will all point the responsibility to each other. And the reporting tool that you are using, that are based on timestamps and some Boolean flags, are not enough for you to understand the root cause of each failure. So your team has to spend dozens of hours manually crunching data using Excel. And this scenario is based on actual experience when I was working as a performance manager and analytics manager in international distribution operations. Today, we are going to experiment the usage of Claude model. So here, the latest model, Opus 1.6, connected to the distribution planning data, so including warehouse and transportation, to help us basically answer basic or advanced questions. And the idea here would be to take very difficult scenarios where we have conflicts between teams to understand how Claude is able to understand the data behind and provide an answer that will help us to find the root cause, but also to implement some continuous improvement journey. So I will first introduce the context, and then we are going to test the different scenarios together to see the potential of these models in helping you improving your distribution operations. So as a distribution planning manager, you are in charge of the efficiency of the distribution chain. So let's imagine that a store requires like 3 bags for a specific SKU. So the order, like an inventory alert, will be sent to the ERP. It can be automated, or it can be your supply planners in your team that manage that. And then an order is created that is sent to the ERP. The ERP will transmit that to the warehouse management systems, and as soon as it's received, the team is able to prepare the order. So they will pick the products, put that in boxes, then in pallets, load that in a truck. Why is that complicated? Because as a distribution planning team, you are in charge of the on-time delivery. So for instance, if a store like here, which would be in Nanjing West Road in Shanghai, calls you, tells you that for the last 10 days, only 60% of orders were delivered on time, you are in charge, or the performance manager is in charge, but usually the performance manager is inside your team, of explaining why the performance is not good, but also providing an action plan to improve the performance. The distribution is extremely complex. So here, I have summarized for this specific scenario that is coming from an actual scenario, what happens between the order creation and the store delivery. So as I told you, the order is created in the ERP, then is received in the warehouse management systems, and there is a cutoff time. So all the orders that are received after 6 p.m., they will have to wait 24 hours. So here you have one source of failure. If the transmission is not on time, you can face issues from the IT perspective. You will miss, the orders will have to wait 24 hours to be prepared. Then the warehouse team prepares the order, they start the preparation, they end the preparation. And then when the order is prepared, the truck should arrive. So here, this is another source of problems because sometimes the trucks don't arrive on time, but they have to leave also on time. So here you have to make sure that the warehouse team and the transportation team is coordinated. Then the trucks goes from the warehouse to the airport. It should arrive before the cutoff time. So this is here like a very specific example. If you miss the cutoff time, but you miss the flight, so you need to wait another 24 hours, then you have all the variability of the flight time. And this variability can impact the start of the custom clearance because for some countries, the custom clearance also have a cutoff time. So here, just without entering into the details, between the order creation and the store delivery, what you have to imagine is that there are so many reasons of failures. And that's what we have implemented in the past, and that's what we implement in LogicGreen in what we call more like business intelligence or reportings. Basically, You create dashboards where you are comparing the actual timestamp versus the expected timestamp using service level that you have implemented inside your company. And then you are able to build some visuals that will show you if you are on time or not. All these processes are interdependent. A slight delay in one process can affect the rest of the chain. So maybe in your reporting, this specific process will be on time, so there will be no flag, but then all the others will be delayed. So then, when you go to the team, everybody will put the responsibility to each other. So as a distribution planning manager, it's difficult because you will have to mitigate all these conflicts, because in the end, what you want is to know the root cause of issues so you can implement action plans. And as I said, static dashboards, they have limits, because the limits are on how you have defined the different flags and different KPIs that you have implemented. And this is why, if you worked in analytics like I did, you are always frustrated because the teams will always ask you if they can extract the data from the dashboards. So that's why in this experiment, we have tried to connect Claude model. So here we took the latest model Opus 4.6 to shipments data. And the idea will be to use Claude to answer simple or more complex questions. And the idea here is that you ask the question in plain English to Claude. Claude knows how to navigate inside the data because thanks to the implementation using MCP, it will perform the right data collection, the right data processing, and give you an answer in plain English, and even show you some dashboards. And this is what we are going to see here. So maybe before giving you the demo, let me just show you what Claude has on hand. So this is an MCP implementation. We connected Claude to tools where they can extract data. And this data looks like this. So we have compiled all the data from warehouse transportation systems inside a single table. So you have the order creation time, it's basically under our responsibility when we are creating the time. Then you have the responsibility of IT, so the transmission of this order from the ERP to the warehouse management systems. We have a first flag to check if it's transmitted on time. Then we have the whole responsibility of the warehouse. So when they start to pick, when they finish to pick, when they start loading, and if they have loaded on time. And then we have the road transportation. So we check when they arrive in the airport, if they arrived on time. We have a Boolean flag here. We track the flight, when they landed, the custom clearance at the different countries. So for instance, if you are going to China for this Nanjing West Road store, when the truck is leaving the store and when it's arriving at the store. And the store has a kind of a cutoff time. I mean, at certain hours, it cannot receive products, and we have this flag, this called delivery on time. And then here we calculate the delivery time, the lead time in hours and in days. So this is basically what Claude has on hand. We added some explanation in the MCP implementation to explain the context, how the flags are calculated. But now with that, plus the explanation, we will see how we can answer the complex questions that we have for him. So now we can put ourselves in the shoes of our distribution planning manager. So let's imagine that she has a lot of issues managing the expectation of stores that are complaining about delays, but also all the different teams that are putting the responsibility to each other. So you go to her and say, look, don't worry, now I have something for you. You can ask the AI to solve your issues. What would be the first concern? But the first concern will be definitely hallucination. You say, okay, how do I know that the answer provided by the AI is coming from the data and not coming from actually some hallucination that the model would have? So for that, what I do usually is that first I put logs inside my MCP implementation. So I know exactly the type of calculation that was done by the model. So I know that it has actually used the data to answer the questions. And usually I propose the user to test the AI with a random question. And here, the random question is just to ask, so okay, I am a distribution planning manager in charge of the logistic performance. So first, do you know that I will use you? For your information, so Claude can be equipped with multiple tools, and here there is a tool called lead time management or something like this. So it should know that when you talk about logistic performance, it should be linked to this tool. And yeah, I want to use the lead time tool. This is how I called it. Could you please explain me in a concise way, using table if you needed it, what Boolean flags you have on hand and how you can use it? And here, this is where you can see the power of Opus 4.6, sorry, is with the minimal settings that I've put in my MCP implementation, it understood exactly how the distribution chain is working. So all the different flags, so after EDI transmission, pick and pack loading, airport on time, and then, so that's the explanations. And to be honest with you, in the MCP implementation, I haven't tell Claude how to answer the questions. I just told the tool what you have on hand. And here, that's one of the things where I saw the potential of this tool is that Claude himself, or herself, itself, proposed a kind of approach to solve the issues. And first with the layer 1 quick diagnostic. And this is what maybe we can link to the normal reporting tool, where you only look at these static dashboards with reason codes implemented. And that's the first thing it will do, the layer 1. And then it will analyze the true root cause. And for that, and this is exactly what I expected from Claude, is unlike what the reporting tool will do, so looking only at the Boolean flags, I want Claude really to go in the details to analyze the different timestamps, maybe to find some additional insights that were not implemented in these static rules that are connected to the Boolean flag. And this is exactly what Claude understood. And this is why, for me, this tool has such a potential. And it even gives you a kind of a scenario where flags alone will not solve. So warehouse runs 2 hours over on pick and pack to loading time. The airport is on time is false. The landing on time is false. The delivery on time is false. So basically all these Boolean flags will be at false, except maybe the one of the warehouse. But the responsibility will be on the warehouse. It's because here, and that's the key part of these complex problems, is that it's not only about being on time or late. It's about how the cumulative delays of the previous processes can impact later the chain due to cutoff times, because cutoff times are fixed, but the lead times between processes are variable. And this variability, this cumulative variability that you can have due to the different processes upfront can impact you. So for me, this first answer was quite satisfying. So now I could test the model with an actual case study. And here, one of the scenarios that I saw a lot of time is that as a distribution planning manager, you will look at the dashboard. You will see that, for instance, for this flag, like for instance, delivery on time, you have 2,084 shipments that missed this flag. And your assumption is that is due to the leg just before. So here, the last mile delivery. So for instance, if your shipment is leaving from Paris, taking the flight to Shanghai, and then from Shanghai to the Shanghai store, you will assume that the truck arrived late at the store because of the transportation from the Shanghai Pudong airport to the store. That's probably the reflex that you would have. And this is exactly what we assume. So we assume that it is due to the last mile delivery between the airport and the store, which is under the responsibility of the local team. And they are arguing, they're saying, no, it's not due to us. We saw some delays in the airport and during the custom clearance. So here you need to have some arbitration because it is key for you to find the root cause. And you have two teams, so the air freight and custom clearance team and the local team that are fighting to know which team is which team is responsible for the delays. So you ask this question to Claude. If there was no Claude, what you would do, you would go in the data, you would filter out all the shipments that were delayed, and then using the flag, and then you would check case by case. Maybe you would implement new Boolean flags. Here, you just ask Claude. So, great question I have. This is completely useless. So what Claude is good is reasoning, but also how to present the data. So here, you have a mix between, I would say, business executive summary and detailed explanation. And here, the first answer can be considered as a business executive summary. So the local team has a valid point, but they are not entirely right either. And this is key here. The model is able to provide some nuance. And this nuance will be backed with data. And here, what happens is that it's usually like a common scenario where the flag-based approach is not showing the actual primary cause. And here, what happens is that on the flag-based mode, so if you only look at the flags that have been implemented by the business intelligence team based on requirements that were like maybe 1, 2, 3 years old, the air freight is only responsible for 14%. But when you analyze in details the different delta and the cumulative delays, that I told you about before, the air freight responsibility jumped to 38%. And this is exactly what Claude is explaining here. So it explains you in plain English what is the difference. I don't know if I asked, here I didn't ask, but what is good with Claude, unlike other models, is that since Claude is very data-driven, very code-driven, it will use a lot of tables that you can use later to explain that to your management or to share that in communications. And here, so this table is quite clear, showing that it's a mix between road transportation and air freight. And why? So provide a statement, I would say the business executive statement, and then explaining why. And here is exactly what I expected from Claude, and he didn't ask Claude to do that, is to analyze the variability of the lead times and to show that the transportation leg from airport to stores has a variance that is pretty low, which means that they are doing their job, and the fact that they may be late sometimes is due to the variability of the flights that you can see here, where you have a standard deviation of nearly 110 minutes. So that's the detailed explanation. I will share with you the complete analysis via a link here. You have the conclusion with the verdict that you can directly share to the teams. And then, of course, you can go deeper to say, okay, what would be the type of action plans? Maybe can you give me some details of which store are affected? I didn't enter in that details, but here is just to show you that you start with a general statement, and then Claude is able to dig into the data to give you the explanation. And this is nearly at the quality that if you have done yourself, you can check, of course, how the calculations are done. And in another example, I asked Claude to generate the Python code, but here, because Claude is not using Excel, so that way I can replicate the same analysis. And in the end, you have a nearly ready to be communicated recommendation and conclusion that you can share with your management and the store teams and the different teams involved. So this is the first scenario of conflict. The second scenario is more about provide me like a general overview of the performance. So here, for instance, we have all these orders that are delivered not on time. Please explain me which team has the highest contribution into the delays. So this is something that could be done via a dashboard. But here, unlike the static dashboard, you have more comments, and what you will see is like more subtle comments. So for instance, here is explaining that air freight is a first contributor, and this is what we discovered in the previous example with 38.3 of the late shipments. And here, that's what the dashboard will not tell you, is that the flag-based approach that you have implemented that is already inside your system only attributes it to 14%. But so here, what you learn, maybe like for long-term continuous improvement, is that the way that you are calculating the different flags that are static rules that you have implemented in the past are not reflecting the actual reality. And sometimes you cannot know that before implementation. You implement and then you face issues. And here, thanks to the AI, you can automate this kind of analysis to understand if you should maybe readjust the rules that you have provided. And then it provides some additional details. And the last thing that I wanted to show you is also the capabilities of Claude to provide nice visualization. So here in the last interaction, I wanted Claude to prepare a kind of a comprehensive analysis of each team responsibility and prepare me a dashboard. And that's what he prepared in less than 2 minutes. So here you have the overview with always this approach of having a kind of a business executive summary and then more detailed analysis. So using nice visuals here, taking into consideration the previous, like the context, we asked 2 questions where the answer was, be careful, the flag-based attribution is different from the true root cause analysis. So here, basically, this dashboard is fed not only by your question, but also by the interaction that you had with Claude in the past. And then the root cause attribution, the process analysis. There is no need to go into the details. You can do that when I will share with you the discussion. But the idea here is to show you that now it will not replace distribution planning teams, but you have a kind of an assistant that will help you to get the most from the data. And I would say the most, more than what you could have with static dashboards. So if you have any question on how I implemented this tool, how I will deploy that for some customers, don't hesitate to use the comment section, and see you for the next experiment.